Hello everyone, we are here to discuss lesson 11-3 where we're going to talk more and more about rational expressions. Rational expressions again are things that make sense, things that you can easily define. And the first thing, again this is 11-3, rational expressions. The first thing that we're going to discuss is reviewing more about finding excluded values. So rational expressions. Excluded values, if we're looking at an example, like on example 1, where we have a negative 8 over r squared minus 36, you'll remember that our excluded values are going to be anywhere where the denominator is equal to 0. So the easiest way to find our excluded values is to set the r squared minus 36 equal to 0. When we find what r is, when all of this is true, that's going to give us our excluded values. So the easiest thing to do is say r squared equals 36. They take the square root of both sides. R equals plus or minus 6. Okay? So as a double check, if I put a plus 6 in here, 6 squared minus 36 is going to be 0. We are going to have no solution when the denominator is 0. If I put a negative 6 in there, negative 6 times negative 6 is 36. 36 minus 36 is 0. So again, we're going to have no solution when r is equal to a negative 6. So we have two places where there are excluded values when r is 6 or negative 6. Let's try another example. This example is letter 1b on page 684. It is n squared over n squared plus 4n minus 5. That is our expression, and we need to find where the denominator is going to be 0. So what do? When is this denominator 0? Well, let's find out. N squared plus 4n minus 5 equals 0. When, how are we going to solve for that n? Do you remember how we can do that? You could use the quadratic formula because this is a quadratic equation. It might be easier to factor. So again, we need to find, if we're factoring, we need to find numbers that multiply to negative 5 and add to a positive 4. Multiply to a negative 5. So that would be like negative 1 times 5. And if we add these together, we get a positive 4, right? We like that. So that's going to be n minus 1 or n plus 5 equals 0. That means n equals 1 or a negative 5 will be our solutions. And if n is a 1, we should get a 0 on the bottom. 1 plus 4 is 5 minus 5 is 0. So if n is 1, we do get a 0 on the bottom. That's an excluded value. Or negative 5. Negative 5 times negative 5 is 25. Plus 4 times negative 5 is negative 20. So 25 minus 20 is 5. Minus 5 is 0. These are both going to be excluded values. Notice that it does not matter what the numerator is. The numerator can be anything. We only will not have a solution if the denominator is equal to 0. That's where the problem is going to be. The numerator could be anything. But if the denominator is 0, we're not going to have an answer. I want you to turn to page 684 and do 1A. Do 1A and pause this video and come back when you're done. I mean it. Pause the video and come back when you have attempted 1A on your own. Okay, so you have paused the video. You have got the solution. You want to see if you got it right. So we have a 5x over x squared minus 81. And you paused it and tried it on your own, right? This is your last chance. You need to do this. Pause it. We're going to have trouble only where the denominator is equal to 0. So we set that x squared minus 81 equals 0. X squared equals 81. X equals plus or minus 9. That's going to be our excluded values, plus or minus 9. I want you to do the same thing for 1b. Pause it. Pause the video. I mean it. Try it again. Here we go. This problem is 3a minus 2 over a squared plus 6a plus 8. And you paused it and you've tried it on your own. And now we're going to find the answer. Remember, the only place where there's no solution is going to be where the denominator is equal to 0. This happens at a squared plus 6a plus 8 equals 0. I could do the quadratic formula, but that's a whole lot of work. So let me see if I can find numbers that multiply to 8 and add to 6. Well, 2 times 4 multiplies to 8 and adds to 6. That makes us happy. So a plus 2 times a plus 4 equals 0. A equals negative 2 or negative 4. Those are the excluded values. Okay, you got those excluded values down. You know what you're doing. That's a good thing. Let's look at this real-world example at the top of the next page. It says, find the height of a cylinder that has a volume of 821 cubic inches and a radius of 7 inches. It has a height, a volume. Our volume equals 821 inches cubed, and the radius is going to be 7. We want to know the height. How are we going to figure that out? Well, if you have a cylinder, you might have forgotten some of this information, but if you have a cylinder, you should know that the area of the base is going to be, the area of the base is capital B, that's going to be pi r squared, right? And the volume of the cylinder is going to be the area of the base times the height. Well, the height is what we don't know. Do we know the area of the base? Well, we can figure that out. Let's just put all of this together. Pi r squared times h. All I did was substitute all of this in for there. And we know what the volume is. So let's just put the numbers that we know in and see what it's going to be. The height is the height from there to there. And you know what a radius is. So 821 equals pi. Well, we know that. Do we know r? It says r is 7. So 7 squared times h. Let's see. That's 821 equals pi, whatever that is, times 49 times h. Well, I could divide 821 by 49, and then I will have pi times h. I could also divide by pi on both sides, and I'll have h is 821 divided by pi 49, or 49 pi. You put all of those numbers into your calculator, you should get h is equal to approximately 5.3. How's that? Make sure you put these numbers in your calculator and you get 5.3. If you don't get them, talk to me, because there are a couple of common mistakes that people make. And if you're not making them, I don't want you to start making them. But if you are making them, then we need to figure out how we can get you to stop doing that. Okay? So make sure you do that. You might want to put your denominator in parentheses. If you didn't do that the first time, make sure you do that and see if that helps you get the right answer. If it doesn't, then talk to me in class because we will figure this out. Okay. We are going to go down to the next example on page 685. It says, which expression is equivalent to negative 3x squared times 4x to the 5th, all divided by 9x to the 6th. Okay. Well, let's look at the numerator and figure out what we can simplify here. I've got a negative 3 and a 4. If I multiply those together, what do I get? I sure hope you said negative 12. I have an x squared and an x to the 5th. If I multiply those together, what do I get? Did I get x to the 10th? I hope not. I hope what you get is an x to the 7th. When I'm multiplying the bases with exponents, that I have to add the exponents, because this is the same thing as x times x. This is x times x times x times x. 1, 2, 3, 4, 5. And if I multiply all of those together, I should get x to the 7th, right? divided by 9 times x to the 6th. Well, 12/9 is just a fraction, and if I simplify that, I should get a -4/3 because 3 goes into both of those, right? And x to the 7th divided by x to the 6th is going to be just an x. You could think about it as x to the -6 up here, and then when you add the exponents, you get just a 1x to the 1. So this is what we get. After we do that problem, since this is multiple choice, we want to make sure we look at the multiple choice answers and see which one is the right one. And we find out that, in fact, it is D. D is the correct solution. I want you to try number 3 at the bottom of page 685. I will write down the expression. The expression is 16c squared b to the 4th divided by 8c cubed b. And you are supposed to simplify that or find an expression that is the same as that. In this case, we're just going to simplify all of this up. So you go ahead and pause the video and see what you can come up with on your own. And we're back because you paused it and you honestly tried to work it out on your own. So that means we're going to simplify 16/8, which simplifies to just a 2. Now I have a c squared and I have a c cubed on the bottom. The things that we know are that we only like to have positive exponents, and we have to simplify this so that we get only positive exponents. So if I've got a c squared on top and a c cubed on the bottom, I could bring it up so that bring this up so that it becomes a c to the -3, but then I'm going to have c to the -1. So I'd rather bring this one down because that's going to leave me with a positive c to the +1 on the bottom. Now b is here on top, b to the 4th, and b to the 1st on the bottom. So when I simplify this, I am going to get a b cubed. Okay. If you don't remember why this is, please go back and review stuff from chapter 7. You could also go to a website that I just gave you, and I can't remember the name of it. It's ixl.com or something, and you can review these sorts of problems there as well. So if we look at that, let's see, in my book, this answer is answer A. I hope you got that as well. Okay. Just a few more example problems. Let's look at example 4. Example 4 is 2r plus 18 divided by r squared plus 8r minus 9. Anytime we're going to see a rational expression, it means that we're going to have something that is expressed as just a fraction. So you can see this looks a whole lot like a fraction. But does anything reduce here? Well, I don't know. Let's see. The easiest way to see if it reduces is to factor everything that you possibly can. So if we look at the numerator, is there anything that factors? Is there a GCF? I sure hope you said 2, because a 2 is common to both of those. When I factor a 2 out of the first term, I'm left with r. Then I have a plus sign. And when I factor a 2 out of here, I get a 9. If I multiply that 2 through, if I distribute the 2 through, I should get this again, because I'm not actually changing anything. I should have exactly the same value here. It's just that I'm writing it in a different way. How about on the bottom? Is there anything common on the bottom? No, there's nothing common at all. There's not an r in all 3 terms. But can this factor into something that is the opposite of FOIL? Can I find numbers that multiply to -9 and add to 8? Multiply to -9, if I have a +9 times a -1, that would add to an 8, right? Gosh, you'd think that I've been doing these for 20 years the way that this just happened so quickly, right? Okay, so if this is the way that we can do this multiplication to a -9 and add to a +8, that means we can factor it as r plus 9 and r minus 1. Now everything here is factored out as much as we can factor it. And we can see that we have an r plus 9 on the top, and that's only multiplied by something. This whole r plus 9 is one group, right? And this r plus 9 is also a group on the bottom. So when we have these groups like this that are only multiplied by other things, then we can cancel them. And we're left with a 2 over r minus 1. Now, I want to make a big deal about this because sometimes students will see something similar to maybe a 2r plus 9 over 2r, and they say, oh, these cancel, so the answer is 9. No, 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 don't do that. Please don't do that. The whole idea here is that you can only cancel like this if you're multiplying the whole thing that you're trying to cancel by everything else in either the numerator or the denominator, okay? So please don't do this kind of thing. Make sure that you're multiplying anything that you're trying to cancel by everything else in that side of the fraction. Only when you're multiplying can you cancel them. Okay, let's do another example so that you can get a better idea of what I'm talking about. But first we have to finish this problem. Not only do we have to factor it and simplify it like we did here, yay, we did that, but we also need to look for excluded values. What is in the denominator? When the denominator is equal to 0, that's going to give us our excluded values. So we can see right here from where we factored that if r is 1, we're going to have a 0 for the whole denominator. So 1 and negative 9 are going to be the excluded values. Okay, don't forget to include that, because even in that final answer, it's only 1 that is an excluded value, but that's not what we started with. We have an excluded value up here from the equation that we started with, and that value is also going to show up in our solution set, that we cannot have an answer at that point. Okay, let's do another example. 4a, I'll do this one with you. We have an n plus 3 divided by n squared plus 10n plus 21. Well, I don't think anything can factor out at the top, but what about the bottom? We need to find things that multiply to 21 and add to 10. How about a 3 times 7? We like that, so that's going to become an n plus 3 over n plus 3 times n plus 7, okay? Now this n plus 3 is a whole group. I could put that in parentheses and I wouldn't change anything, right? And because that n plus 3 is a whole group and it's being multiplied by, well, you could say it's multiplied by 1, and there's an n plus 3 that's a group on the bottom that's being multiplied by something else, I can cancel that n plus 3 out, and I'm going to get a final answer of 1 over n plus 7. Okay, again, we have to look for those excluded values. The excluded values are going to be when n is equal to a negative 3, n equals negative 3 or negative 7, and those are going to be the excluded values. And that is the entire answer to that problem. Now it's your turn. I want you to try 4b on your own. 4b is y squared plus 9y minus 10 divided by 2y plus 20. Pause the video and try it on your own. I mean it. Every single one of you. Okay. Can I factor the top? I need to find something that multiplies to a negative 10 and adds to what? 1? No, adds to 9. What multiplies to a negative 10? Negative 2 times 5, but when I add that, I get a positive 3. That's not what I want. How about a 10 times a negative 1? That multiplies to a negative 10, and it adds to a 9. So that means the numerator is going to turn into y plus 10 divided by y minus 1. What about on the bottom? What can I work with on the bottom here? Do I have a GCF? Yes, I have a GCF, so that my GCF here is a 2. And when I factor a 2 out of the first term, I'm left with y. And when I factor a 2 out of the second term, I'm left with a 10, but don't forget the plus sign, so y plus 10. And again, if I check this work, I can multiply 2 through and I get 2y plus 20. I should get exactly what I have there. What is the same on the top and the bottom? Same on the top and the bottom. The whole group that I can cancel is a y plus 10 and a y plus 10. And I'm left with a y minus 1 over 2, which could also be written as 1/2 times y minus 1. And what are any excluded values? Well, this 2 doesn't change anything because 2 is never ever going to be 0, right? But inside this set of parentheses, if y is equal to a negative 10, I'm going to have a problem. So y equals negative 10 is my excluded value. And so this is my answer. You could have your answer look like this or this, either one of those, but make sure you include your excluded values. All right? Okay, you work on that for a little while. I'm going to have one more video about 11-3 part 2. You just keep working on this and practice, and we will talk later.